I'm going to talk a little bit about the distance formula, the midpoint formula, and then equations of circles. So, like I said here, sometimes we want to find the distance between 2 points. And what we have here maybe is a point P that has coordinates x1, y1, a point Q that has coordinates x2, y2, and I'm going to try to find this distance D between them. That's the length of this line segment. To do that, I'm going to form a horizontal line from P and a vertical line from Q and have those intersect at a point. Where they intersect, I'm going to call that point R. Now, I can figure out the coordinates of R because of the relationship it has with P and Q. Since R is at the same vertical height as P, if I connect R to P and keep going, I'm going to intersect the y-axis at the same y-coordinate. That means the y-coordinate of P has to be the same as the y-coordinate of R. Since I knew P had the y-coordinate y1, that means R has to have the same y-coordinate. The same sort of thing happens with Q and R. If I extend that, I get to the same point on the x-axis. So the x-coordinate of Q, x2, that must be the x-coordinate of R. So that's how I got these coordinates of R. It's the same x-coordinate as Q and the same y-coordinate as P. Then to find these distances along from P to R and Q to R, I noticed going from P to R, the y-coordinate stays the same, so I'm just changing x-coordinates. So I just subtract the x-coordinates to find the distance. For Q and R, that's a vertical distance. I do the same thing, except I subtract the y-coordinates. And now what's important is the fact that D here is the hypotenuse of this right triangle. And the Pythagorean theorem says if I square the hypotenuse, that's equal to what I get if I square the other two sides and add them together. And that's what I've got here on this first line. If I square the hypotenuse, that's the segment from P to R squared, and then from Q to R squared. So then I take the square root of both sides, and I get this thing called the distance formula. So let's see how this works. I want to find the distance between these 2 points. So I can start by writing down the distance formula. So I just copy it down. And now I have to plug in these values. If it helps, you can label these points. It doesn't matter which one is point 1 and which is point 2, but I could say that that's x1 and then y1, and then this is x2 and y2. Now, this is going to sound a little silly, but I've seen students make mistakes with this before. Be sure you label one as x and one as y. Don't make both of these x and both of these y, right? We got to have one x and one y for each set of points. So now I just substitute in these values. x2 we've got is -3, x1 is 1, and then y2 is 7, y1 is 5, and so I get -4 squared plus 2 squared. That's 16 plus 2. No, not 2. 16 plus 4, which is the square root of 20. Now, if I do the square root of 20 on a calculator, I get that the approximate value of that is then about 4.47 if you round that on a calculator. So you would have to take the square root of 20 on your calculator. To get the exact value, square root of 20 is the exact answer, except I should simplify that. I can rewrite 20 as a product. I can say that's the same thing as square root of 4 times square root of 5, and then the square root of 4 is just 2. So the exact answer would be 2 times the square root of 5. And again, you can even do 2 times the square root of 5 on a calculator, and you'll get 4.47. So that's how I use the distance formula. We also sometimes want to find the midpoint of the line segment between 2 points. So here I've got the same point P and point Q with those coordinates. I want to find this point M that's halfway between the 2 points. If it's halfway between, that means this distance and that distance the distance between P and M and the distance between M and Q, those distances have to be equal. It turns out that if I use these coordinates, oops, I've got a mistake here. This is not X again, these should be Y's. So y1 plus y2 over 2. It turns out that that will give me the midpoint. So let's test this in this example. So here I've got this point with these two values. Again, I can label this x1, y1, x2, y2. And if I want to find my midpoint M, x is going to be x1 plus x2 over 2. So x1 is 1, x2 is negative 3. So that's going to be negative 2 over 2, which would be negative 1. My y coordinate is going to be y1 plus y2 over 2. So that's going to be 5 plus 7 over 2. That would be 12 over 2, which would be 6. So I get that my midpoint is the point negative 1, 6. Now I'm going to show that M is really the midpoint by calculating these distances. So my point P is 1, 5. My point M is negative 1, 6. So I can call this x1, y1, x2, y2. And my distance, using the distance formula, x2 minus x1 squared plus y2 minus y1 squared. So x2 now, I've changed a little, so it's going to be x2 here, negative 1 minus 1. And then y2 minus y1, 6 minus 5. So that's going to be negative 2 squared plus 1 squared. So that distance is the square root of 5. And then if I want the distance from M to Q, well, M is negative 1, 6. Q up there is negative 3, 7. And I'm going to call this then x1, y1, x2, y2 for this distance formula. So I plug in, I get negative 3 minus negative 1, and I get 7 minus 6. So that's negative 3 plus 1. So that's negative 2 squared plus 1 squared, which is again the square root of 5. And so I see that those two distances are equal, so that's pretty convincing then that that really is the midpoint. Another thing I could have seen, if we go back to the first page here, we calculated that the distance between P and Q was 2 times the square root of 5. And we just saw here then that distance to the midpoint in the middle is just square root of 5 on both sides. So that's half the distance from P to Q. So this midpoint formula really is doing what I want it to do. All right, so what about circles then? Well, a circle is a set of all points. I'm saying in a plane. If we don't specify that, if it's in 3 dimensions, then this definition would give us a ball or a sphere. But if we restrict ourselves to a flat surface, and we have this fixed point C, that's called the center of the circle, and we've got this fixed distance R. All these points then on the circle itself, point P is just one of them, all of those points would have distance R. So I could draw in other points, right, and those would all have a distance of R. I can find the equation of this circle by just using the distance formula. So If we're doing the distance from C to P, that has to be r. So I'm going to take x2 minus x1 squared, y2 minus y1 squared, and then the square root. Actually, when I do the distance formula myself, I never actually remember this formula. I just know I have to subtract the x's in square, subtract the y's in square. It doesn't really matter what order you subtract in. If you subtract in the other order, it changes from positive to negative, but since it gets squared, that doesn't really matter. So I plug in h and k and x and y. My radius is r. I square both sides, and I get this equation here, which we say is standard form of the equation of a circle. Okay, so this is a very common form that we're going to use. So the easiest types of problems here, these next two examples, just write the standard form of the equation of a circle with center 0, 0 and radius 6. So that's my h and my k, that's my r. So x minus h squared plus y minus k squared equals r squared. So that's going to be x minus 0 squared plus y minus 0 squared equals 6 squared, which is just going to be x squared plus y squared equals 36. In this next example, I get a different value for h and k and a different value for r, but we still have the same basic equation. So x minus negative 3, y minus 2, and I get the square root of 7 squared. So that's x plus 3 squared plus y minus 2 squared. Square root of 7 times square root of 7 is just 7, and that would be my answer. So find the center and radius of the circle whose equation is x squared plus y squared equals 16. So that's x minus h squared and y minus k squared and then equals r squared. So here, x and y, nothing's being subtracted from x and y, so that means h and k would both be 0. If you ever just have an x squared alone in the equation of a circle, that means that the x coordinate of the center is 0. If you have y squared alone, that means the y coordinate of the center is 0. So this circle, the center, is going to be 0, 0. And my r squared is 16, so that means r itself is going to be the square root of 16, so that r is going to be 4. So my center is at 0, 0, and then I'm going to move 4 in each direction. So move 4 to the right, move 4 up, move 4 to the left, and move 4 down. Those 4 points are on the circle, and then we just connect to get the circle. Try to get it as nice as possible. I'm not going to be looking at your artwork on anything like this. Then find its domain and range. Remember, domain is a set of x coordinates on the graph. So the farthest to the left this graph goes is negative 4. The farthest to the right is positive 4. So the domain is going to be from negative 4 to 4. For this particular circle, it turns out the range is going to be the same. The range at y, the bottom point has a y coordinate of negative 4, and the top has a y coordinate of positive 4. So the range here would still be from negative 4 to 4. It's not always going to be the case that the domain and range are the same. We're going to see that in this next example. So again, this is going to be x minus h squared plus y minus k squared equals r squared. So I see it's x minus 3, so my h coordinate is definitely 3. My y coordinate needs to be y minus k, so y minus a negative 2 would actually be y plus 2. So my k value is negative 2. And what we sort of learn is whatever is in the parentheses with the x and the y here squared, To find the center, it's always the opposite. So it's sort of what would make this 0. So I take the opposite of negative 3 and get positive 3. I take the opposite of positive 2 and get negative 2. My r squared is 4. So that means r is the square root of 4, or 2. So my center is the point 3, negative 2. So that's down there. Then my radius is 2, so I need to move 2 in all directions. So I move 2 to the left, I move 2 up, I move 2 to the right, and I move 2 down, and I connect those points. And then I find the domain and the range. Remember then the domain would be my x-coordinates. If I look at this here, farthest to the left, that's an x-coordinate of 1. Farthest to the right is an x-coordinate of 5. So my x-coordinates go from x equals 1 to x equals 5. The range would be the y-coordinates. So the y-coordinates, I look how far it goes up and down. My lowest y-coordinate is down here. That's negative 1, negative 2, negative 3. That's negative 4 is my lowest y-coordinate. 0 up here is my highest y-coordinate. So again, here my domain and range certainly aren't the same. Finally, these were nice problems because I had standard form of the equation of a circle. We do have something else called general form. If I take something like what I had back here, if I take an equation like this and I multiply it out, so I make x minus 3 times x minus 3, y plus 2 and y plus 2, I do FOIL, I combine like terms, I do some rewriting, I would get an equation that looks more like this. This is called general form. It's a perfectly good equation, but it's just not very useful because I can't look at it and tell what the center and radius are. Like here, this equation is written in general form. I don't know what the center and radius are, but if I'm a little tricky and I complete the square, I can make that work. So here's how I do it. I put the x stuff together. Oh, first I move the constant to the other side. So I want to move that over, so I'm going to add 36 to both sides. Then I'm going to rewrite the left-hand side so my x stuff is together, and then I'm going to leave a blank. And then my y stuff is together. And then I'm going to have equal, I've got 36 over there now, right, because I added. And now I complete the square. Remember how I complete the square? I make sure that my squared stuff has a coefficient of 1, which both x and y do here. I'm going to have to complete the square in this problem twice, once with x and once with y. Remember, to complete the square, I take half the coefficient of x in this case, so that's 1/2 times 4, and then I square it. That's going to be 2 squared, which is going to be 2. So I'm going to have my x squared plus 4x. No, what did I do back here? Two squared is not 2. 2 squared is 4. So I get x squared plus 4x plus 4. Now over here, where I've got this 36, that means now I have to throw in a plus 4. And then for my y's, I take half the coefficient of y, so that's this negative 6. So I take 1/2 times 6 and square it. That's 3 squared, which is 9. Now you could say, oh, you made another mistake there. It should really be negative 6. Well, I don't really have to worry about that. Half of negative 6 would be negative 3. Negative 3 squared is still positive 9. So that's really not very critical. So I would get my y squared minus 6y, but then I'd have to throw in a plus 9, and whatever I do to the right, I have to do to the left. So now I should be able to factor both of these as perfect squares. So x times x gives me the x squared. 2 times 2 gives me that 4. And if I put pluses here, then I get outer gives me plus 2x, inner gives me plus 2x, which is where this plus 4x comes from. Same thing with the y's then. I'm going to get y times y. The 9 came from 3 times 3. And to get negative 6y, I'm going to have both negatives. So again, I get negative 3y from outer, negative 3y from inner. That gives me the negative 6y here. And when I clean up, 36 plus 4 is 40. 40 plus 9 is 49. So I get x plus 2 quantity squared plus y minus 3 quantity squared equals 49. And now I can see what the center and radius would be. Remember, for the center, I look at these values and I take the opposite. So x coordinate becomes negative 2, y coordinate is positive 3. The radius is going to be the square root of 49, which would be 7.